is now starting. All attendees are in listen-only mode.
Hello, everyone. This is Larry Hagstrom at the Marine Technology Society San Diego chapter. This is our monthly webinar where we are exploring and interacting and talking with different robotics clubs, maritime robotics clubs around San Diego. Today we have our human-powered submarine club from UC San Diego. Before we get started, I will make a quick pitch for Oceans 2021 starting September 20th here in San Diego. It's an in-person event. If you're a student, we're looking for volunteers. If you're industry, please sign up and join us for our event, Oceans 2021, at the it's not the Town and Country in Mission Valley, San Diego. Now, without further ado, we will get started with our presenter. I think we're starting with Sharron Perez of the UC San Diego Human-Powered Submarine.
Good afternoon. I'm Sharron Perez. I'm the current captain of the Human-Powered Submarine team at UC San Diego. I'm joined by three of our members, Antoinette Gautier, who is our team lead for the documentation team and also works with the hull. We also have Jack Donohoe, who is our drivetrain manufacturing lead. And we have Aryian Schreiner with us as well, who is our drivetrain team lead. So a little bit about our team. We are completely student-run. We have very little to no faculty interference unless we need to speak with UCSD on certain policies. We are made up of a lot of majors. We have no preferences in terms of whose background, or in terms of background for people and experience for people. It's all a case of if you want to learn, if you want to put the work in, if you want to put the hours in, you're welcome to join our team. We have quite a few focuses when it comes to what we work with. We work a lot with 3D CAD. We're using a lot of SolidWorks to design our parts. And we also use the GrabCAD program in order to share our parts with each other and make that a little easier to work with while we're working over the cloud. We do a lot of fluid dynamics analysis as well. We like to use ANSYS. We used to use COMSOL. We work a lot with resin and composites. If you can see behind me, actually, I'm at our sponsor's current workplace. There's a lot of fiberglass behind us, and that's what we work with mainly to make our hull. It's resin, it's UV resin composites with fiberglass. We also work with a lot of metal manufacturing. We have to machine steel and aluminum for our drivetrain. And we also, of course, do our mechanical assembly processes in order to put together the entire project. So the main goal of Human-Powered Submarine, of course, is to make a human-powered submarine. We make something like a bit of a bicycle drivetrain laying down your stomach inside a flooded submarine hull, and then we race that with international teams. So the goal is to make a functioning submarine, first of all, and then hopefully get higher up in the ranks with our performance as well. This year, because of what's been happening with the COVID pandemic, our original plans did call for an ocean launch with in collaboration with our Scripps Institute of Oceanography, and we would work with them to try to launch it off Scripps Pier. But now it's looking like there's going to be a more official race happening in the summer, EISR, and it's going to be happening in Europe. If you also look to the left of the screen, you can see that we have our submarine, Santiana, from 2018. That was a propeller-based submarine design. And this year we're doing a non-propeller submarine race. A non-propeller submarine design. So yeah, the project this year, we have a tuna tail. This is a bit different from another design we've done where it's a bit of a dolphin tail, if you are somehow familiar with Vaquita. We are also working with mechanical steering this year instead of using electronics because we have very limited physical resources. It's all possible that in the future we might go into electronics, but we will discuss that later in the presentation. Our whole manufacturing is occurring at a sponsor's facility, and we stuck to, of course, COVID pandemic protocols in terms of safety, limited numbers, masked in the same workspace. And now we are on hiatus over the summer because of limited people in the area, but we are hoping to pick up the process of manufacturing coming up. And then the drivetrain design is almost completely CAD'd out, and we are working on the cams, the tooling paths. We also have a CNC mill that we have purchased, and we have begun the manufacturing on some parts. So the team is made up of 4 sub-teams. We have our drivetrain sub-team. They work on most of the mechanical components, the bicycle-like system that gives us our propulsion. We have our hull sub-team. They design and manufacture the outer shell of the submarine that encases our pilot. We have, of course, our human submarine interface and steering sub-team. It's all put together into one sub-team. That's made up of our pilot, our safety divers, and everybody who designs the safety measures and the steering, because it's big to make sure that you have a way to get your pilot out in case something goes wrong. And we also have a newer sub-team this year. We have our documentation sub-team. They are in charge of making sure that we have recorded progress of what we do. They've also created a new website for us, and we have a new wiki system that's been implemented. It's very exciting to have a way to pass on that knowledge as we go on. So next up, we have a speaker. Jack, if you can talk about what's happening with drivetrain.
Hello, yeah. So in drivetrain, throughout most of last year, we were working in SolidWorks doing CAD on modeling our entire new submarine. Most of this was just because of the pandemic. We had a lot of issues with construction and in-person work, so CAD was our best way to really get a lot of work done and incorporate new members into the flow of things. So at this point, we pretty much completed the entire CAD of the submarine, and there's a working model of it where if you turn the pedals, moves the tail and all that stuff. We just need to finalize it in terms of like making sure all the exact dimensions are right and making sure that all of our parts, are feasible to manufacture. We pretty much checked that out, but just a couple little things we need to look at. But other than that, we're pretty much done with that. And so we've moved on to generating toolpaths in Fusion 360. So to move from the CAD to manufacturing it, especially on CNC machines, we're creating toolpaths. Fusion 360 is what we've been using because it's a cloud-based server and it links up to our new machine, which is the Shapeoko, pretty well. The Shapeoko is a desktop CNC machine, so it has like a 30 by 15 inch cutting area that we can use to manufacture aluminum, which is great because almost our entire drivetrain is made out of aluminum. So we've been tuning and calibrating that. We spent a lot of time with that. We've started doing a couple parts, but most of the time we spent recently has been getting the machine dialed in so that we can make really precise parts. Because a lot of our tolerances are pretty small. So we've been really working on that. We've acquired most of the materials we need to make all that stuff. But yeah, so now we've pretty much transitioned from the design to the manufacturing phase. So that's kind of where we're at now. Here's a couple models of what we've got going on. So on the left is kind of our completed CAD of the system. It's a render, and it's not super easy to see the details of the exact drivetrain, but the video on the right is a really good example of how it works. If we could just play that. So the pedals turn, and then basically the pedals turn, which then gets converted into a different direction of rotational motion with a right angle gearbox. And then we have something called a spherical linkage, which translates that rotational motion into sinusoidal motion, which generates that propeller motion we see there. So that was our general design. We had a little bit more complex design before COVID came around, but we had to really simplify it. But we're still really excited about it. The spherical linkage is something that we've never done on the sub team, and we're really excited to introduce. It's going to take a lot of testing, but hopefully it should all work out good. And it's a pretty simple and elegant design. We're pretty happy about it. Yeah, and here's a little wireframe that's a better example of what's going on, but it translates from, you see the pedals there, and then a chain connects to the right angle gearbox, which is this next feature as you move to the right, and then it moves on to that boomerang shaped thing that you see there. That's the spherical linkage, which converts to sinusoidal motion, and that's actually attached to a hex shaft. So when that hex shaft is rotating in a sinusoidal way, it then swings the boom arm sinusoidally, as we saw before. Aryian can talk a little bit more about what's going on with the tail. He's been our spearhead lead on that recently. So we'll leave it away to him.
Thanks, Jack. Next slide. There we go. So it might have been a little bit difficult to see in the last couple slides, but this is the new iteration of the tail. It's changed a lot in the last year. A lot of design considerations, specifically, we're yet to do mesh testing and understand, which, regions of the tail have critical forces. We're yet to do materials research, whether, we can stick with aluminum in some parts. We need fasteners for the CAD at the moment. As you can see from the design, there aren't any bolts or nuts, placed in the CAD yet. We're yet to look at our third-party vendors for specific components. We also need dampening methods. It might have been a little difficult to see in the last slide in the video, or the second to last slide. But we have a lot of moving components that need to switch direction really quickly. So there's some research to be done there. As for the end of the tail, the airfoil, there's a lot of research to be done. We know that there's going to be a lot of force at the end of the tail, as it's, the point of the submarine that, where all the force kind of converges. So, there's some research to be done there, and creating that airfoil itself is going to be a challenge for us as well. We've gone with a couple designs over the last year, or the last couple of years of the submarine. We're kind of between 3D printing with an exoskeleton and vice versa, having a soft exo and hard internal components of that airfoil. As for the future, obviously nothing ever goes perfectly to plan. We plan to use the time after we assemble the submarine post CAD to smooth out some rough edges and create solutions to unexpected problems we might encounter. I guess we plan to get our new members dive certified so that we can get this thing in the pool. I guess, yeah, we'd like as many hands on deck, or hands under deck. We're going to run into issues, and that's part of the process. I imagine that specifically the drivetrain, where all the moving components are, we're going to find some issues with water and aluminum components. We're going to have to find stainless components, but that's part of the process, and we look forward to it.
Hi, so I'm Antoinette, and I work on the whole team a bit. So this year we made pretty slow progress because of the pandemic. We managed to repair a plug that we had made last summer, and then make a mold from that plug out of fiberglass, like Sharron mentioned. Here you can see a picture of our first attempt at laying up the first half of the submarine from that mold. But there were some issues with specifically the resin we were using. We were changing the viscosity a bit to experiment with that, and we had a drainage issue, and we also had maybe too thin of a gel coat. Anyway, so this is a bit of a failed first attempt. Yeah, you can see we tried to sand off any bumps that came from these little pockets of resin that have formed, but in the end we decided that it was not worth saving. Yeah, so that's where we're at now for the hull, and progress is stopped over the summer because of a lack of space right now and a lack of people to work on it. Yes. So our future plans for the hull is to continue consulting our sponsor and mentors. at Sunres, who've been helping us a lot in making the submarine. Here you can see a picture of us laying up that first half of the submarine. Yes, and then for fall quarter, once we can actually start working again, we have to actually make the submarine and attach it together. Of course, assemble, like add the drivetrain and steering mechanisms. And then we have to find out a way to manufacture the nose cone so that we can actually see out of the submarine. Otherwise, that would be pretty difficult for the pilot. Yes, so we have several in-person work days planned, or we're hoping to be able to work several times per week and hopefully on campus.
All right, so for our steering mechanisms, most of our mechanism is going to be similar to the one that we used for Santiana, and there will be some changes. We're going for a splitter system where you have the controls for both the top and bottom, and then the left and right fin pairs for our steering. You can see that in the upper right. Also, we will be having something different with our pilot interface. We'll have throttle-like controls. We're going to have adjustable levers so we can have more flexibility for the maneuvering. We're going to have levers with three-hold attachment points so that the pilot interface and the fin interface have those cables going on. And then we're going to have attachment points for the mechanical advantages of 1, greater than 1, and less than 1. It's easier to see on the next slide what we're talking about. So you see we have the fin pairs going on with the throttle. You have those splitters with the Morse cable for our controls. And then you have your 3-hole attachment points on the upper right. You'll need more force or less force depending on where you place your cables. You can also see on the bottom, we have our previous throttle system and some other steering stuff going on there. For, let's see, future plans for HSI and steering. Of course, because of the COVID pandemic, we have a lot of setbacks. So initially, we were deciding to take a less risky approach with steering and going for a fully mechanical system and not going for an electrical system. We are also incorporating previous mechanisms from other submarines in order to assist us in making a fully operational steering system. However, now that we are making a little bit more progress and things are looking up for us, it's possible that we will experiment with an electronic steering system in terms of, using a potentiometer for our microcontroller, and also having a cyclodal gearbox to increase the torque of the motor, and experimenting with that and trying that out. There are some benefits of having an electronic steering system. Of course, it's a lot more space efficient. You don't have to worry about having too many things to transfer that much power, and it's easier for the pilot to control. However, it does require trying to power the system, and it does require more maintenance. And also, when you have electronics underwater, waterproofing is very important for that.
Okay, so for documentation, which is kind of the newest team we have in the larger team, our main work has been manufacturing logs, or kind of just recording our progress for the mainly drivetrain team and hull team, just to kind of keep track of our progress and the pitfalls and successes we have, because most of the information, technical information on how to make a submarine so far has been passed on by word of mouth throughout the team, and that was not really going to be as possible during this virtual year, so we decided it was important to write down exactly what we were doing. So here there's a screenshot of one of our wiki pages that's the drivetrain team has been using to log their Shapeoko runs and the feed and speed calculating. So that's the main work for documentation. We're also working on the website, just making it generally prettier, and other wiki articles explaining other technical parts of making a submarine. So we're hoping to do more video tutorials and incorporate more images to make it more visual. In the future, we'd like to have an even more, like an even easier process for adding information to the wiki. So we would want to have an on-site editor, since right now we're relying on kind of more coding knowledge and like third-party things. So we would want to have an on-site editor with like more complex formatting options, and just make it generally more user-friendly for other members of the submarine team to use. And hopefully we would also work on making a private database for our own more sensitive information, like passwords, sponsor contact information, and even our own like internal meeting notes.
All right, so with the start of a new academic year coming up, we are looking to expand our team. We had a lot of people leave with this graduating year, but we're hoping to get more people interested in the team, and we're hoping to get more information passed on to them. So a big part of recruitment for UCSD organizations is tabling. We have things like Welcome Week, which happens during the beginning of the year for freshmen, and we have just general library walk tabling, engineers on the green. Library walk tabling it's a road right in front of our giant library. You can see actually in the picture above, that's our Geisel Library. There's a road that branches out from there, and then we set up booths on the sides, and then we try to appeal to new students or any other students who are looking for organization with our submarine. And then we have Engineers on the Green, which is JSOE, Jacob School of Engineering specific organizations. It's typically organizations that focus on STEM and engineering and such. We also hope to use more of our social media to reach out to people. In terms of recruitment, we have an Instagram page, and we also have a Facebook page, and those are more active nowadays. We're trying to get posts out once a week on the weekends, Saturdays or Sundays, and just trying to keep people updated with what's going on. There's also now with the virtual learning scheme, there's Discord. Discord is a big service that's basically giant chat room servers, and it's a way to connect to students in your department or in specific classes or in specific years. So being able to have a moderator, you know, boost our organization and have an announcement that we're recruiting is an incredible opportunity to reach a lot of ears and a lot of eyes too. And it's becoming useful in the past year as well, when we're looking for more people who are interested in getting some experience even during a virtual year, because it's so important to have a head start when it comes to not just classroom knowledge, but also more applicable hands-on or even just like working with a team knowledge. Also not mentioned here as well, we are looking to reach out to diversity groups. We have groups such as OSTEM at UCSD, which is out in STEM, and they are an LGBT-based group. There are also other organizations that are based around racial demographics. We hope to reach out to more of the Chicano, Asian, and Black communities when it comes to what we do, and we want to look to diversify our team and give more opportunities to different people. In terms of recruitment is pretty much a continuous process, especially with the virtual learning and virtual stuff. It's really easy to, just with a few taps of the fingers, send out a message, see who's interested, and also it's easy for people to reach out to us and express interest, and then we can try to get them on something. But typically our main recruitment periods are at the beginning of the year and the beginning of each quarter, when people are transitioning into new schedules and trying to figure out what they want to do and what they want to try out. And we, of course, always encourage anybody who is interested to try things out. We have a chemical engineering major who was the lead for our whole team. And I myself am aerospace engineering, so not really anything super involved with the water, but it's still something that interested me and I wanted to get into it. Okay, and plans for the future and beyond. Of course, we want to complete our current project, Calypso. She is the priority of the team, her completion, and we are looking to compete in EISR, the European International Submarine Races, that take place in the UK on one of their naval bases, unless there is a change in plans that is announced later on. But otherwise, it's looking like we will be competing this summer in person and in Europe. So that's very exciting. We're also hoping to secure a workspace for the team on campus, preferably indoors. We are working with faculty and speaking with them on having a space where we can basically store everything and work inside and out of the elements. If that doesn't work out, we do have something we call the cage. It's a giant, basically a giant fenced off cage, and that's our main storage space. But we have worked out of there before. If we have to work out of the cage, we'll be working to basically make our workspace entirely modular. We have some designs for tool caddies and for workbenches that can be moved around and shifted around and expanded in order to optimize our space and make sure that we have as much area to work as we can. So we do have a contingency plan in case we can't work indoors. We are also working towards getting machine shop certifications. There are specific classes offered at UC San Diego that if you take it and you pass, it'll grant you access to working with the machine shops. That's going to be very important for us, even while we have our newly purchased Shapeoko, our CNC router. It's still important to have access to the bigger machines and the more professional machines as time goes on, especially with the kinds of parts we'll be looking to manufacture as we go on. It's also just an important skill for anybody who wants to go into engineering to have. It's good to know how things are made, of course, and have that better idea of how to design things more effectively for the manufacturing process. We are also going to be pushing for more scuba diving certifications. We have a sponsor that we work with that gives us some pretty good discounts on getting those dive certifications, since we are one of their bigger customers and we keep going to them every year. Dive certs are very important for the pilot and, of course, safety divers. That is pretty much the main requirement of those parts of the team. You need to know how to communicate underwater. You need to know how to use the equipment safely, and you need to know how to help each other safely if anything were to go wrong. And in the future, we, of course, want to stay social with other organizations. So we are looking to have cross-organization social collaborations. We have had some in the past. We've had bonfires, and we've also recently had game nights, virtual game nights online. And it's just nice to keep everybody connected and have a sort of sense of community and this sense of like lifting each other up and helping each other. Thank you for coming to our presentation this afternoon. Thank you for making the time. I hope you all enjoyed our presentation, and if you have any questions, Larry will conduct those. I suppose that's all we have for now then.
All right, fantastic. Great presentation, all. Let's see. We're waiting for some questions to come in. We did have a comment and an offer come in while you guys were talking. Dave Horrigan.
Stop my share really quick. There we go.
There we go. Can you hear me okay? All right. Dave Horrigan, one of our longtime members, and genius, I would say, is offering up, what do you call it? A one-time license to the solid water propeller, which he's trademarked, I guess. So he says in the question, and I'm going to just, I'm going to kill this. The fish caudal Fin Cycle. Am I saying that right? Caudal? Are you guys even familiar with that? So Caudal, Fin Cycle. I Google it real quick. It's a real thing. It's, it's a tail fin going back and forth. So he's got some software that he's willing to offer up for a one-time license. And I've put his email and his phone number in the chat there. Can you guys see that? Okay. So I'm going to leave that to you guys to follow up on.
Let me make a note of that right now, and I'll reach out to we'll reach out to Dave about that.
Yeah, and look up Dave.
Thank you for your offer.
Yeah, look Dave up online. He's got some interesting patents and whatnot. All right, but he has left the presentation. He says he had another presentation to get to. All right, let's see. Here's another one. Okay, from Robert Wernley, he says we can give a booth at the conference to the team and they could display their vehicle. So yeah, this is what we were talking about before, and I'll put that in part of our my announcement at the end. But again, to anybody who's listening, that we will have Oceans 2021 starting September 20th down at the Town and Country in Mission Valley. And we are offering our student clubs booth space to present their machines. So what's the name of the machine you have currently built already?
The one that we have built, the closest to the mechanism that we have, her name's Vikita. She is a dolphin tail design.
Great. Okay. I think that's what we saw like a year or 2 years ago when we did the last presentation a couple years ago. Cool. Yeah, if you guys could bring that down and we'll put it up in a booth, and if you've got a little banner or something and flyers and all that, we'll spread the word. All right, any other questions coming in? Got that. Oh, Harlan, where's Harlan? Harlan asks. Okay, sorry guys, this is not easy to read here. Okay, he says won't won't visibility be a big problem through a plexiglass nose cone? And 2, how about a small through hull with a GoPro or similar camera in lieu of a nose cone?
Let's see. So none of us, I'll let Jack speak on that.
Yeah, so the plexiglass nose cone I know has been, it gets foggy and it's not like the best for visibility. The nice thing is that it is like a pool setting, and luckily in most of the races, the buoys and stuff are pretty brightly colored, so we can see it pretty well. But I think we actually have in the past talked about using like a small camera for visibility, especially if you want to look in any direction other than directly straight forward. And I think we've definitely talked about that and considered it. I think this year for the nose cone, we haven't done a whole lot of talk about it, so we'll definitely give that some consideration. I think it's actually a really good, cool idea to advance our visibility for sure.
Very cool. Yeah, and if you are using a camera, it wouldn't be too far of a stretch to get somebody to program sort of a horizon in there so that you can kind of see if you're drifting off course or your angle of attack is too high or low or flat, and to keep it as efficient as possible. So with an IMU. All right, anybody else? So we've got Harlan, Robert. Let me check the chat. Nothing in the chat. Give it a minute, guys. Some people might be typing. All right. There's all kinds of little interactive buttons on this thing. I can tell who's watching and who's being inattentive. Rita Chin. All right. So let's move forward here. We will go ahead and thank you guys, and I will make a few more announcements. And what I will do right now is attempt to share my screen. Let's see if I have that. I don't think I have that capability.
Thank you again for the opportunity to present, Larry.
Oh, sure, no problem. And, you know, next year we'll be doing these in person. And I mean, the webinar's fun, but, you know, it's better in person. All right, what screen are you guys seeing right now?
We're seeing your desktop.
Ah, now what are you seeing?
Now we see the Oceans Conference.
Okay, great. So I'm going to promote my little slice of the Oceans Conference first. It is the golf tournament. We have put on golf tournaments in the past. This is a big 18-hole full press golf tournament. Will be happening the Sunday before the meeting starts. It's actually the 19th. I don't know how the 9th got in there. The Sunday before the event. And we are looking for sponsors. There will be raffles, prizes, lunch, carts. You don't have to walk 18 holes. Prices are showed right there. Hole sponsors are $500. Lunch sponsors are $500. And then any kind of raffle tickets you guys can put up would be great. All right, that's the end of my pitch. I'm going to put this up. And now, Oceans 2021 is at the conference center down at the Town and Country in Mission Valley. We've had very high attendance in the past. This year is our first year after COVID, so we're optimistically keeping our fingers crossed. And for this group, it would be really great to see all the commercial presenters down. So there'll be a trade show floor, and with all kinds of things, anywhere from, you know, AUVs to sensors to buoy tech, you know, and offshore wave generation. So there's all kinds of neat stuff, plus all the presenters, all the white papers, and that. So with that, I'm going to stop sharing my screen, and I would do one last pitch for volunteers. So again, you get a free T-shirt. You don't have to be there every day, but you know, a couple of days or a one day, whatever you can throw together, that'd be great. And we're not asking a whole bunch of you, but you know, pointing people in the right direction and information, and or even just, you know, watching an area. So with that, I think we've done pretty well. If you guys have any last pitches or requests from the audience, remember this is being recorded and we'll have this posted, so it'll have a little bit of a life on the interweb. So Sharron, any requests for anything? I mean, you did put in
Yeah.
Covered space. I got that one.
Yeah. I think a big part of what we're looking for is a means to make a nose cone. And also we're looking to make a let's see, we need material for our fins and our tail.
I'd say, also related to the tail and the fins, we could use some expertise on, specific like computations and math surrounding, what kind of material we're gonna need, and sweep of the tail, like the specific angles that we're looking for. There's a lot of intricate math there that we could get really precise with, but right now it's pretty abstract.
We could use a lot of mentor guidance in figuring out where to start with that, because I mean we kind of know we're going to probably need to do fluids analysis, but it's also kind of good to have somebody who has a better grasp of those sorts of mechanisms and those sort of mechanical properties.
Right. The chemical engineer that Sharron actually referenced earlier was helping us with most of the research in that sense, but unfortunately she's graduated and no longer with the team at work meets, so it's hard to communicate with her regarding intricacies of the research that she did while she was here. But yeah, we could use some help with that too.
Great. All right. So, without further ado, I want to thank UC San Diego Human Powered Submarine Club and for their presentation, and then thank everyone else for attending. Thanks a lot. And oh, of course, here is one more question right when I'm about to end this thing. All right, talk with Leanne Thompson. Leanne at Aki. Oh yeah, sure. Company makes caudal fin vehicles. All right, thanks, Harlan. Well noted. I have Leanne's email, and let me see if I can throw that in the chat, and if you guys could grab it real quick. So, Leanne with an E, Thompson. And they make a really cool AUV, really, so it doesn't have any tethers, but it looks like a giant tuna. And they got a great contract for to monitor fish farms up in Northern Europe. All right, do you see that in the group chat? All right, so yeah, reach out to her. She's really friendly, and really bright. So I'm sure she's felt your pain. All right, well, thanks again. That's it. Let's sign off, and stay tuned to this channel for more presentations from the Marine Technology Society in San Diego. Thanks a lot. Bye.
Thank you, everybody.
Thanks, guys.
Bye.